Hi, good afternoon to those in Asia, and for South Africans, good morning. We're gonna do a simple demonstration on how the solution works, both in an air-gapped environment as well as a connected environment. So first off, let me just share my screen. So this is the victim machine that we're going to demonstrate the solution and how it works. So it's a Windows machine, as you can see, and I'm just going to disable the network card. And once I do that, practically we all know what's going to happen. It's the endpoint is totally disconnected from anywhere, including the server that's going to manage the solution, right? So if we're going to disable this network card now, we practically will not have access to anywhere else, and I only have one network card just to demonstrate the endpoint is totally offline. We can see that there's a cross button down here. It says that's not connected to anywhere, and now the network card is totally disabled. So under such a circumstances where you may have situations like this, it is an air-gapped environment or even a closed network or temporary, you just don't have the connection that you wish that you have. And in certain cases before the COVID and in the near future, when we're able to travel, this kind of situations will become very prevalent. When people are on the airplane, you will have airplane mode when you don't have any connection at all. And precisely during these times, you probably will want to do some of your own work, or maybe you have downloaded some games and you want to play with it during the time of isolation. So just let me just verify that the internet is totally gone. I don't have any connections to the internet now, and I should not have any results from Google if I do a test from the Google browser. Okay, so there's no internet, that's fine. And under such a circumstances, I'm just going to run a malware, which potentially could be something which the user downloaded before he bought on the flight or go into this isolation mode, or just temporarily cut off from the internet. So this is the first application that we're going to run, and put, well, the name of the application just gives it away, but it could be named as any application that you could be aligned to, like maybe it's a game or some kind of chat application. But in this case, when it is run, the ReaQta Hive agents automatically monitors the behaviors of every single process, and it tries to understand whether the process behaves in a malicious or suspicious way. And in case of this particular application, is a Maze ransomware. It behaves in the ransomware behavior where it tries to access certain files and try to encrypt them. So while it is on this, our AI engine, which doesn't require any kind of updates or upgrades, will automatically detect such a threat. And because it is a high impact process that potentially can encrypt your files, the ransomware engine automatically stops the process on its track. And there you will have a prompt that tell you that this application has violated a policy. And if you click OK, you can see that the files and everything still intact. There is no harm done. Even in an isolated environment when there's no connection to do any kind of update, there is no back-end cloud to reference to or signature database to reference to. So we're using AI engine that sits on the local machine to detect the threat and to block those threats if they're creating a high impact to the endpoint. So the next moment when you have access to the Hive server, this information will then be passed on and send it back to the Hive server, and you'll be able to understand that the endpoint has suffered from a threat. So when you go to the dashboard, this is the dashboard that we manage the solution. And if you just wait for a while, the data will be transferred to the dashboard, and you can see that the endpoint has suffered from a ransomware behavior attack. So you can see that there are two alerts. So this is actually a early stage warning. The detection strategy gives you an idea of a particular behavior that exhibits before the ransomware encryption. So if you look at this particular alert, there are some information on the right-hand side. This information gives you an idea of what is the trigger, the key activities, and also the endpoint information. If you click on the view alert, you will go into the alerts details page where most importantly, this is the behavioral tree that will give the analyst all the information that he needs to solve the problem. So we can make it a full screen and just zoom in a little bit. You can see that the Maze ransomware actually started WMIC, which is a Windows application. And the first thing that it does is that it would delete away shadow copy. Now, this is one of the threats of the Maze ransomware, and it's also something that makes it very powerful because once the Maze ransomware starts to attack your endpoint, if you're using any kind of backup solution that leverages on shadow copy, those will be gone, and you are not able to recover them. So the first thing before it starts to encrypt your stuff, it will just delete away shadow copy to ensure that no restoration of the data is possible. So we detect this kind of behaviors at a very early stage before the ransomware behavior exhibits itself. And of course, once the ransomware starts to encrypt your data, this is where we trigger another kind of alert. This is the behavior analysis alert, possible ransomware detected for Maze RW. And if you click on this view alert, you will see the similar kind of information displayed in the previous graph. We have the WMIC that deletes away the shadow copy, but now you have more colors and more shapes onto this graph. So from the Maze ransomware, one of the key things that we can see is that there's this ransomware behavior, and it's trying to encrypt your data. And of course, we do have also in-memory executable. This is another kind of detection. So we actually place a lot of roadblocks in front of the malware. And if it just steps on any one of them, those will trigger, and you will have the recording of everything that happens. And of course, in case of a ransomware behavior, we automatically stopped it so that no human is required to intervene and to respond in a manual fashion. So this is just one example of the behavioral tree that provides you with most of the information. And if you go down below, you have all the events that's recorded down here. And if you just scroll to the last page, you can see that the Maze ransomware matched a protection policy whereby we will terminate the process automatically. And this is done obviously without human intervention. And it provides the kind of automated response that you require in terms of high impact attacks. And let's just go back to the victim machine again, because these two threats these two alerts has been blocked already. So there's really nothing that the analyst needs to do. Of course, you can close it as malicious, and the AI at the back end will learn about this and understand what do you mean by malicious or what do you mean by benign, and starts to tailor-made to every organization, detecting things that is out of the norm for that environment. If we go back to the victim machine again, I'm just going to show you very quickly another ransomware, and I've just found this like 10 minutes before the talk. So basically, why do I want to show this? Is this is the Revil ransomware that creates the headline for Apple 2 days back. So the story is that one of the manufacturers for Apple has been breached, and they suffered the ransomware attack. And I think the attackers are asking for like $50 million or something like that. It's a Taiwanese manufacturer. And it happens that this Taiwanese manufacturer, the name is Quantum, is manufacturing notebooks and PCs for Apple. So of course, Quantum didn't budge, and they didn't reply to the ransom request. And now the Revil attack group is reaching out to Apple to ask for the money and the ransom instead. And looking at such a huge company, I'm pretty sure that you have like, different kinds of organizations, small, big, medium size, different kinds of organizations. But if you look at Quantum as like a huge company, and you know that they have antiviruses, you know that probably have more than one antiviruses, and these security solutions in place to protect that organization of that size, of that value, and it still fails to detect and protect them against such a ransomware attack. So what really is the problem? The problem is what Dan mentioned previously, is most of the solutions that's leveraging on traditional technologies and also we're playing a catching game, right? So if you have a new signature, you need to update it before you're able to, get the protection out of it. But at the same time, if you are the first target of the attack, there is no signature to update from. There is no reference, or there is no detection from known attacks, because you're the first victim. It is targeted attack, and you just can't prevent this from happening. So you need a technology that is future-proof. And this is where the ReaQta AI engine comes into play. We do not require any kind of updates. It is capable of detecting the behaviors regardless of whether it is released today or is going to be released tomorrow. The malware is going to be the same. When we look at a malware, it is first time that we look at it. We look at the behaviors of it. If it exhibits the behavior, we don't really care whether it's an old one or a new one. We will detect and we will block them all the same. So we're just going to execute this one. It's going to take some time. Ironically, because this one requires administrative privilege to run, so I'm just going to give it administrative privilege. But if you just imagine the human weakness, right? Imagine that this ransomware tries to run on a PC in quantum, and somebody just willingly give it the administrative privilege, and it just runs with administrative privilege like any other applications. So human weakness is besides the point. We know that it's always going to be a problem, but besides leveraging on human awareness or security awareness for your stuff, we want to have a solution that is future proof, that is able to detect the threats, and on top of your antiviruses, that protects the organization to give you that kind of behavioral analysis that you require. So we just have to wait for a while. And if you look at the task manager, let me just see whether it's still running, hopefully. Yep, it will take some time to run. But at the same time, if you look at the dashboard, we do have already some detection on it. So I'll just explain along when we show the different detections that appears on the dashboard. The first thing that you have noticed that this detection is a little bit different from the previous one. This one is a cloud policy. All right, so we do have a cloud intel. So if you sign up with the ReaQta solution, you do have multiple engines for detection and protection. Well, we have the on-premise and on every agent, the AI engine that does the detection in automated format using behavior analysis and also the machine learning algorithms. But we also have the cloud checking. So we have our own cloud intel sources, and we check with those sources to see if any of these matches. And if yes, then what we can do is to basically trigger the alert based on cloud. What do you call that? The Hive Cloud. So if you go to view the alert, you look at it, it's the initial stage of the detection. And it just shows you that the trigger point is this reval, having this hash, and it starts a copy of itself with a different process ID, of course. And we detect the starting of the application based on the knowledge that we have on this application. All right, so if you just wait for a while, and then it will just automatically create the policy, the Hive Cloud will block the process, right? So that's the ransomware detection on different kinds of use cases, online or offline on an air-gap environment. So it really depends on the different need and requirements for every organization. We do have detection that works in every requirements for your customer, be it a totally air-gap environment or online environment, or even a hybrid environment where you have an on-prem server that is taking and serving all your endpoints locally, while you have also roaming endpoints that is able to connect to the same server for the same kind of detection and protection. And of course, going to the threat hunting, which is also another use case that we have for our customers, is besides doing the detection and blocking, there are actually a lot more things to do with our solution, understanding what has been run, what is unauthorized, what potentially you would not know. So if you just ask the simple question, do you know what your neighbor is running at the moment? Now, if the answer is no, Then the next question is, in such a scenario, how would you expect to detect threats in real time? Now, the keyword is real time, because it doesn't really matter if the threat has been run for like 5 minutes or 10 minutes, but if it starts to create that impact, the impact is going to be created before you do the detection, and the detection is late. And once the detection is late, you cannot salvage the situation. You cannot revert back to the state before the attack. So we want the detection to be real time, if not near real time. So the question is about visibility, right? So just imagine that you have specific requirements to hunt for specific threats, or even to look at the visibility of the organization. The first thing when you go into the threat hunting page, you are greeted with these three logics, the OR, AND, and NOT. And of course, this provides you with the different capabilities to zoom into what you want to find using the different logics. And also, we do have events that we support. For example, one of the use case could be account lock-on failure. So if you search for account lock-on failure, you can see a bunch of account lock-on failures that potentially could be a brute force. And if you want to zoom into a specific time, maybe I just want to look at 0 hours to 06 hours, where I don't really think anyone will come to work such early. At this early time. So if you see that there's a bunch of account lock-on failures, that may signify that somebody is doing some automated lock-on, and perhaps it's a brute force attack. Another use case could be things like if you have an authorized VPN solution that you use for your organization, and you're just wondering if somebody else uses certain VPN that is not authorized. So one of the key things that you can find could be things like OpenVPN. So instead of finding the event type, we're going to find things like path. Maybe we just look for if anyone is running a OpenVPN from, let's say, OpenVPN folder. We can do that, and you just click on any of this result. You can see that it is from C drive, program files, VPN connect, but I'm not even typing the full string. All right, I'm just typing a partial of the path, and we're able to find that for you in a very quick and response in a very quick manner. So this gives you an idea of who actually runs the application, the endpoint name, the type of events it was involved in. And again, if you click on any of these events, the side panel rolls out, and you can see the details about the application, including the path where it is running from, the user that runs it, and the 3 different hashes. And the prevalence tabs tells you, besides this endpoint, is there any other endpoints that actually runs this before? So that gives you a very good idea of whether this is an isolated case, or maybe you already have this run in certain endpoints or environments that you might not know about. And of course, we're talking about also, sometimes in IT operation, we're looking at not threats, but certain bandwidth throttling applications. If you have one endpoint that uses BitTorrent to download movies, that's fine. But if you have like 500 people that starts to use BitTorrent, that may jam up the network a little bit. And therefore, you might want to disallow certain applications that does P2P, or maybe BitTorrent downloading of huge files. So if you're just wondering if anyone uses BitTorrent within the environment, one of the key things that you can look for is a signer information. And we're just going to put BitT, because I'm not sure whether BitTorrent is spelled as one word or even a split word, but we can put a partial name to it. And again, with just a click in moments, we're not even talking about 5 seconds. We have the results here. And the endpoint names, again, you click on any of them, you can see that this BitTorrent is signed by BitTorrent Inc. And even our cloud score tells us that this is suspicious, because some of our sources identify this as malicious or a potentially unwanted application. The hashes is here, and the path that runs this application is there. So you can see the name. Also, if anyone else runs the same malware or the same application. that gives you an idea of how many people are using BitTorrent for the matter. So we support over 120 different parameters. Anything that you are looking for, you can think of regarding files, processes, and users. Probably some of these parameters are there. So we are looking at things like the hashes, the IP address, destination, source, the user information, whether the application have a GUI. We have also the file system name and the original file name, the path, the signature information, certificate information, the login information. We have registry information, specific MITRE tactic or techniques. We're looking at WMI information as well. And the list just goes on. And coupling with the three different logical operators, it just helps you to zoom into looking at things that you might not think exist in your environment. So that is the visibility. That's the unparalleled visibility that we give you. And you don't have to click on a button and wait for 2 hours for the results to come back. It is just a moment in time. And it gives you that information that you need at your fingertips. And also, let me just maybe use the next 5 or 3 minutes, if I have, to describe about answering the question of what if there is a new behavior. All right, so maybe the behavior analysis kind of solution is not something new to you. You have seen other people talking about it. Some of the vendors also claims that they have such an approach to detect threats. But what if there is a new behavior that is not supported out of the box? There's a new threat, it's a new behavior. We always encounter with such a situation. And traditionally, if you have a new behavior that is exhibited by a new kind of malware, the vendor has to do the R&D, has to release a new version, and eventually it will have to release a patch or even a new version for you to detect this new behavior. But our answer to this is what we call DESTRA. Is a short form for this detection strategy. The detection strategy allows you to basically tell the engine what you want to detect. It's a flexible way of telling the engine to detect specific scenarios that you have. So for example, you may have services creating suspicious scripts or suspicious applications. So we actually use a scripting language called Lua to basically script this behavior and tell the engine that whenever services run, if the process that spins off from services is command prompt or PowerShell, then please raise a alert, and we can give the information that we need to into the alert. And this helps us to detect that kind of scenarios. And of course, the possibility is endless. You can do things like this, which is partially complex, having to understand the parent and child relationship. You can also do things which is very complex, looking out for specific IOCs in specific behaviors. You can also do detection strategy in a very, very simple format, like I just want to know if Notepad runs, right? So this is the use case for you. Whenever we have a process run, we just get the original file name, we match it with the name. If it matches notepad.exe, we'll create an alert. What is the use case for such a thing? Well, thinking out of the box, not just for malicious malware or even suspicious activities detection, we're also looking at what can we do for audit? What can we do for real-time tracking? Right, so we have a customer that actually asked for real-time information whenever WinSCP is run. So WinSCP is an application that does file transfers to servers or endpoint to servers, and they have this WinSCP installed on one particular endpoint, and because this endpoint has access to a very high-value server, that's why we need to understand when is it run. If it's run at, let's say, 10 a.m. in the morning within the working hours, that's fine. But if it starts to run at 2 a.m. in the morning, where we don't really expect people to use the application or the machine, then it becomes suspicious. So therefore, they need to understand this information. So what we do is we just create a detection strategy for them. And whenever a process is created, we just track whether the name is called WinSCP. If yes, then we trigger an alert. And of course, we can make it more complex to look at what is the office hour, and if it's within the office hour, we won't trigger an alert, and if it's outside of the office hours, we can trigger an alert. So the possibility is just endless. And with detection strategy, you do not have to wait for vendors, in this case ReaQta, to come out with a detection for the new behavior, because naturally you will have the capabilities to do this yourself, or even coming back to us and we can help you to script this. And within 1 or 2 days, you do have the the new kind of detection as per your requirements. All right, so I hope this short demonstration gives you a very good idea of how we do detection, protection, as well as threat hunting and detection strategy. And I'll pass the time back to Tristan. Thank you.